Today, we're going to talk just the basics about the geothermal systems. Geothermal systems, as we know them today, is a water-to-air heat pump. What we know in the past is an air-to-air heat pump. All air-conditioned heat pumps simply move heat from one area to another. In an air-cooled heat pump situation, we extract heat from the air outside in the winter and bring it into our home. With the geothermal heat pump, the water temperatures are going to be way more stable, between 45 and 65 degrees. So we can reject the heat into the water more easily, and we can extract the heat into the home. The heat pumps, as we know them today, are all equipped with defrost controls. So when it gets below 30 degrees, anybody seen their heat pump go through defrost when it's cold outside? With using the stable temperature of the earth, we never get the condensation to go through a defrost cycle like that. So geothermal systems do not have a defrost cycle like a conventional heat pump. Geothermal is a solar source of heat. As we can see from the diagram, 48% of the sun's energy is soaked up by the earth. That's what's rewarming the earth every day. That's how we fall under the renewable category. That's how we can take advantage of the tax credits. In the wintertime, you can see from the slide, even if it's minus 30 degrees outside, deep into the earth, it's going to maintain a constant 45 to 55 degrees. And the same in the summer. Even if it's 95 degrees outside, the Earth's temperature is still going to be between 45 and 65 degrees. Geothermal applications. There's 4 basic ways to use the water source geothermal systems. Our first is what we call the horizontal loop field. Our second is the vertical. And then we have a lake loop, and then we have an open loop. The horizontal loop a lot of times can be more economical to install, but does require more land. As you can see, we would leave the house and run a series of trenches away from the house. This illustration here is showing straight pipes. What we typically do is we will dig a ditch 4 foot wide and 7 foot deep, and we'll lay a slinky loop in the trench. That way we get 6 to 8 feet of tubing per 1 foot of trench. In the next slide, you will see a vertical loop system. Vertical loops are slightly more expensive because what we do around here is we bring a well drilling machine in and we drill a series of 6-inch deep holes. They can be 200 to 400 feet deep. We can buy the tubing from Charter, and if we're drilling 200-foot wells, we'll buy 210-foot unipoles of tubing. So it'll already have a 180-degree bend on the bottom of the tubing when we buy it. And we have 10 feet sticking out of a 200-foot deep hole. Vertical loops can be more consistent and slightly more efficient because we're seeking more mass deeper in the earth. Vertical loops like this are great in town. I have a job we did the year before last over in university. We have a series of 8 200-foot deep holes and a 200 square foot front yard. So it does not take very much land to a vertical loop. The next one is what we call a lake loop or a pond loop system. They're not real popular in this area simply because of the mud and the silt we have in our lakes around here. The silt will build up on the tubing and will require periodically cleaning because the silt will insulate our tubing, and the whole purpose for the tubing is to be able to reject heat and soak up the heat from the water. The last one is the open loop, commonly referred to as a pump and dump system. Back in the 70s when my father first started with these units, that was all we did was pump and dump. The pump and dump systems can be cheaper to install on the front end, but some states are already regulating the waste of the water. And a lot of applications, we are pumping 8 to 12 gallons of water through the systems consistently when the heat or the cooling is operating. I've seen people get pretty creative with what they do with the water. I've seen them hooked up to irrigation systems. I've seen them hooked up to fountains and ponds. I've got one customer down in Union County. He buried a 5,000 gallon underground plastic tank. We dump into his plastic tank. He pumps off of that tank there for his irrigation, and we have a spillway on the tank, so when the tank gets full, it dumps off in the creek. There is nothing wrong with the water, except the water may be slightly warmer or slightly cooler than the ground temperature. The loop materials themselves. Around 1979, they came out with polyethylene tubing. That made the loops way more economical to install. This pipe here is made by Charter Pipe, sold by R.E. Michaels, and it comes with a 50-year warranty on it. The joints there's no mechanical joints. We actually use a process called heat socket fusion. We have an iron that heats the tubing up, heats the fitting up, and it's inserted together where it actually melts the polyethylene tubing together, and that's where we get our 50-year warranty from. We never have problems with our joints. We fill the system with a glycol mixture. What we're looking for is freeze protection and a way to transfer the temperatures from the earth back to the coaxial heat exchanger. I've seen glycol methane used, glycol propylene used, but what we're looking for is a non-corrosive freeze protection on our solution. The pump modules have came a long ways in the last 20 years with the way we can buy pumps and size pumps. The software program that Tony's going to show you here in just a little bit, not only does it help us design our loop fields in various configurations, it will also size our pump for us. That way we're not putting a pump on too large for an application or too small for an application. We're not wasting energy. And the 50-year warranty on the pipe. As you look at the components of a geothermal system, you'll see almost all the same components that you have on a normal air-cooled air-to-air heat pump. You have the coil, the drain pan, the compressor, the controls. The de-superheater is an additional feature that's added on the geothermal system. And what this is an additional coaxial heat exchanger that's inside of the unit. We pump domestic water through the de-superheater, and while the air conditioner is operating, we can inject 90 to 100 degree water into the hot water heater. It lessens the hot water demand, so your water heater is not heating the water up from 60 to 120. It's only got to come up from 95 degrees to 120 degrees. And we can actually show that savings on the hot water heater on the software program Tony's going to show you in a few minutes to show you how much additional savings you get for domestic hot water. The auxiliary heaters, like you see in your heat pumps now, when the blue light comes on in the thermostat, that's an auxiliary heater that must come on with an air-to-air heat pump when it gets down below 35 degrees periodically. These units does not require an auxiliary heater until it gets down below 0 degrees outside. We always put auxiliary heaters on our units and wire them to the emergency configuration, so if something does happen to our pump or our system, the homeowner has a way to flip the thermostat to emergency and go to an auxiliary source of heat. But it's not required for day-to-day heating in the home. How the system works, the system's going to work basically just like every other heat pump that you have in your house. The thermostat's going to call. The first thing that's going to happen is the circulating pump come on. It's going to start circulating the solution through the system. The compressor is going to come on, the blower fan is going to come on, and then the cooler and warm air is going to start coming out inside the house. The coaxial heat exchanger inside the unit is where the transfer from the water solution to the refrigerant will happen. We're going to take heat away from the refrigerant and add heat back to the refrigerant inside that coaxial heat exchanger. A few myths and misconceptions from geothermals, the most commonly asked questions that we get about geothermal systems. First question we always get is, I've heard it's very, very expensive. The geothermal systems themselves can be twice as expensive as a conventional heat pump system. The geothermal portion of it will be no more expensive than buying a 19 or 20 SEER heat pump. The additional cost comes in the loop field. It's not hard to get 3,000 or 4,000 feet of tubing in our loop field, so that can elevate the price. The tubing that's inserted in there should be good for 50 years, so it should outlast two geothermal systems. I have units my father put in the 70s that I've seen last 25 years. We replace them, and the loop field should be good for the life of the second unit. In a typical 2,000 square foot home, In a vertical loop situation, we can put that in a 20 by 20 area. I think 10 by 10 may be a little optimistic. Horizontal loops do take more property, and the International Ground Source Heat Pump Association is the organization that helps us design the systems. Like air-to-air heat pumps, all geothermal units aren't created equal any longer. You can buy standard efficiency geothermal units, or you can buy high efficiency geothermal systems. We have integrated two-stage compressors and variable speed fan motors into our geothermal units, making them that much more efficient. Advantages to the geothermal system: homes with geothermal systems have a higher resale value. People are starting to look at the price of the utilities and the operating costs of a home when they're buying a home. Tax advantages on the mortgage. To my knowledge, there's no tax advantages on the mortgages as of today, but they do come and go periodically throughout the year. Building equity in the home instead of paying for the utility bills. Big federal and state tax credits on dramatically lowering the cost of the system. Longer lifespan of a system. If a normal air-cooled heat pump system is going to last you, Consumer's Guide says 12 years, I'm going to say 12 to 15 years. These geothermal systems are lasting 20 to 30 years depending on the water solution inside the system. They do have a much longer life because they're never being taxed with the heat outside. Reduced hot water costs. The de-superheater is one of the most overlooked devices in a geothermal system. Tony showed you how dramatically we can cut the utility bills on just heating our water by using the de-superheater. Lower annual utility rates. Clean, no combustible fossil fuel. We're no longer required to burn fossil fuel to heat our homes. No penetrations in our roof structure. We have no vent pipe on the furnace. Enjoy your back deck. The typical installation of these units have no condensing units. They have no outdoor units. So when you're sitting on your back deck in the summertime, you don't have to listen to your air conditioner or your heat pump operated in the backyard. The tax credit that Tony spoke of a few minutes ago is good through December 31st, 2016. Homeowners can claim up to 30% of the tax credit. Like Tony said a few minutes ago, we're not accountants. Everyone needs to check with their accountant, check with their personal tax situation. As of right now, the state of North Carolina has some of the most attractive state tax credits for geothermal installation.